going to copy this whole thing. Come on, come on. So now we are going to focus on steady state condition. Why? Because the question wants us to determine the steady state amplitude. Okay, so we are going to look at now x as a function of time. SS means steady state. Okay, SS over here means steady state. So this will be equal to F naught over K divided by 1 divided by 1 minus omega naught over omega n squared sine omega naught t. Okay, so we have everything now. So now it's just a matter of substitution. Okay, so if you're going to find the amplitude, we just need to find F naught over K divided by 1 minus omega naught over omega n squared. Okay, so if we were to sketch x as a function of time, we know we will get a response like this. Okay, steady state. So this amplitude over here, this is our what? Amplitude at steady state. Okay, so we have all the numbers. F naught is equal to 2.588, right? F naught, now this is due to the motor unbalance. Stiffness over here is the stiffness of the structure, which you have calculated is 1800 divided by 1 minus by omega naught. Omega naught, that is what has been applied, 20. And omega n is the natural frequency of the structure, which we have calculated is 19.658. And then the whole thing squared. Okay, so this will be equal to 2.588 divided by 20 divided by 19.658 squared. Did I put a wrong value? No, 20 divided by 19.658 squared. 1 minus, okay, so it's minus 0.035. 2.588 divided by 1800 divided by. So it's equal to minus 0.0 40 or 41 feet, or minus 0.491 inches. Okay. So that is the amplitude. So you know, in terms of amplitude, does not matter is plus or minus. You should quote the what? Absolute value. Are we clear? So the amplitude, you should quote it as an absolute value. Okay, why? Because it goes up by 0.491 and it goes down by minus 0.491. And then the last part of the question, it asks us right? We're almost done, okay? So the last part of the question, it asks us the angular velocity. Okay? It asks us about the angular velocity of the unbalanced weight to induce an amplitude of vibration of 0.25 inches. Okay. So again, that's the same thing where we have x. Okay. So this is sorry, not x, amplitude, same equation, is equal to f naught over k over 1 minus by omega naught over omega n squared. Okay. So this question wants us to determine what is omega naught to induce 0.25 inch amplitude. Okay. So we have to be very, very careful down here. Okay. Why I say we have to be really, really careful down here? Because F naught amplitude or F naught is dependent on omega naught. Okay, so you have to remember the F naught has omega naught embedded to it, and we know that F naught is equal to m r omega naught squared. And we know that. So we just calculate what is it. Okay, so now the F naught over here again is due to the what? The motor. The unbalanced mass, right? The one that's inducing the what? Inducing the vibration. Okay. So don't look at the structure. Some of you might say, Eugene, why you don't use the value 4 point what? 4 point the mass of the structure. No, this is we are looking at the what? We are looking at the unbalanced motor. Okay. So now this will be equal to 0.25 divided by 32.2. Radius we know, okay, 10 over 12. Omega naught squared is what we want to determine. So from here, 0.25 divided by 32.2 times 10 divided by 12 is equal to 6.47 times 10 to the power minus 3 omega naught squared. And we are almost done. I know it took 1 hour to do this. Okay, we're almost done. So now we look at the amplitude, right? So 0.15 or 0.25. So now we are going to apply this equation. So we know that the amplitude is 0.25 divided by 12. Why divide by 12? We change it to feet. So this will be equal to omega naught is equal to 6.47 times 10 to the power minus 3 omega naught squared, close bracket. Okay. And then divide by our, how come I drop our stiffness? Okay. So you have to divide by your stiffness. Stiffness over here is how much? It's equal to 1800. Then divide by 1 minus by omega naught squared over omega n squared, we know is equal to what? 19.657. 19.657 squared. Okay. So now we have to solve for this now. Okay. When I saw the one term only, I start to panic a bit because like omega naught squared on the numerator, omega naught squared on the denominator is going to be equal to 0. No, it's not. Okay. So when we bring things over, so 0.25 divided by 12 times by 1800 is equal to, I'll do this again, okay? So 0.25 divided by 12 times by 1800. 37.5 multiplied by 1 minus by omega naught squared over by 19.657 squared, close bracket. And then this will be equal to 6.47 times 10 to the power minus 3 omega naught squared. Okay, let me see again. 0.25 divided by 12 times by 1800. Okay, so it's 37.5, blah, blah, blah. Everything's correct. Okay. So now when I put the term in 37.5 minus by 37.5 divided by 19.657 squared minus by 97.05 times 10 to the power minus 3 omega naught squared. This will be equal to 6.47 times 10 to the power minus 3 omega naught squared. Let me do it. Yes. Oh, okay. 658. You're right. Thank you. And I have another question. You spot a mistake? Someone say something just now. Are we okay? Are you okay? Okay, now let me 37.5 divided by 19.658 squared is equal to, so now it's 0.4. So from here, we get 6.47 power minus 3 plus by 97.04 power minus 3 is equal to 103. So this is equal to 103.51 times 10 to the power minus 3 omega naught square. And this is equal to 37.5. Okay. So 37.5 divided by 103.51 power minus 3 square root omega naught square or omega naught is equal to 19.034 radians per second. So to get the amplitude of force vibration of 0.25 inch, okay, when you rotate at this frequency x, or the amplitude, will be equal to 0.25 inch. Okay. What did I tell you? Force vibration is not so bad, am I right? Right. It is how you assemble the entire system. Are we clear? That's why I emphasize on doing what? Divide this into what? Stages. Okay. A bit of thing that's confusing. Omega, what is omega naught and what is omega n? Okay, I think it's very clear down here. Yes or no? Okay, right. Take a you want to take a 5 minutes break or we go until 6 o'clock? Yes. 5 minutes break. Okay, take a short 5 minutes break. We come back again.